Okay, so welcome again from my side this time, and thank you, Spiros, for this overview for renewable innovative projects all over Europe in the different district heating applications. In my presentation for today's workshop, I will focus a bit more on why we develop or see this the solution we presented in the NEUTRON project as a very attractive solution for the application, especially in Kozani. That's why it's called the Kozani case study. Next slide, please. Therefore, I will just shortly recap what Spiros already presented, the different technologies that are in application on other sites across Europe, and why I see here some special drawbacks why these technologies may not be the first choice in Kozani for the district heating in Kozani. Afterwards, I will just in short recap what the situation in the region in Western Macedonia is in the electricity market, because this is a very special situation in Kozani that no other city with a district heating I know of has in its direct vicinity. Then going towards the NEUTRON approach, why I see our approach being a very nice combination to bring all together these preconditions in the area. Give an example of how the system we propose here could operate in this environment, and in the end, just try to recap the unique benefits that our solution could offer compared to other solutions for green district heating. So it works probably with the works. Yes, it works. Nice. Okay. Just a short recap for some of the technologies Spiros just presented, and how the application of these technologies in Kozani could look like. I think one technology that is largely discussed is the large-scale heat pump. We know there was some projects presented, and there's also I think one lighthouse project at the moment is in Denmark, in Esbjerg, where there's in construction actually the largest heat pump ever built, I think, so far to supply district heating. But one thing is usually these projects utilizing big heat pumps, they are mostly located at sites where there's a reliable low-temperature heat sources available, like heat from a river, or like in Denmark from the seawater, or from lakes. And apparently, in the direct vicinity of Kozani, we do not have such a low-temperature heat source. So what we looked in the first phase of NEUTRON, also in this aspect, is that the only heat source available in large scale is the ambient air, which is not very reliable, because when most power is needed, the ambient air is very cold. So it's very hard for a heat pump to extract heat from the ambient air in these situations. Projects utilize geothermal energy. This is unfortunately, Kozani is not located in a favorable spot for geothermal energy production, because the potential is quite low. I found here a geothermal potential map from Europe, from an EU project, where there's marked the areas where geothermal energy could be used in a good way. Then many projects focus on the utilization of waste heat, most of them from industrial production. Although we see in Kozani there is no heavy industry having lots of waste heat available that could be utilized for the district heating system. And the last that I want to mention here is the biomass, because especially in Austria, for example, many district heating focus in the green transition on the utilization of biomass, wood chips, for example. But here's also the point: wood chips would be a substitution for the fuel, but in the end, there's no big potential to produce them locally. So in the end, such a solution would rely on imported fuel again, like it is done with the fossil fuels. On the other hand, a very special situation in Kozani is that the region of Western Macedonia, I think as you all know in this round, has been always a hotspot of electricity generation. We had this in the introduction presentation from the municipality also. During peak times, what we found, about 70% of Greek electricity being produced in Western Macedonia, mainly by the lignite power plants. During peak times, when all of them were operational, I found data that the installed capacity in the region was about 4.3 gigawatts of electricity generation, with about 3/4 or even more of it being lignite and the rest being hydropower plants. Nowadays, it's already much less because many of these lignite power plants have already been shut down. But this is actually the situation. What I found is what also the electricity transmission grid was built to transport this electricity, this generating capacity to the rest of the country. The transition is already in full, let's say in full run. This is one thing we collected from the source called Global Energy Monitor. It's a database collecting renewable energy projects, and what we see here is already, just in parallel to the shutdown of the lignite power plants, there is already a very strong path for the build-up of renewable electricity generation capacity, both for wind and solar PV. And what we see here is what we found, the total announced and planned and in construction generating capacity from PV and wind, altogether summing up to around 15.6 gigawatts of electricity generation capacity in Western Macedonia, which is 3.5 times the generation capacity that the lignite power plants had during their peak times. So the energy transition is already in full run in the region, which makes it a very special situation, because I don't know of any other city with a district heating network which has this much renewable electricity production potential in its direct vicinity. What is the impact of this rapid increase of green electricity production? What we see already today is also some things from the news that I could find in the internet, quite recent news. One is that the rapid increase of renewable electricity generation is already today leading to a phenomenon called curtailment, which is basically that the electricity grid is not able to transport away the electricity produced during the peak times of the PV plants, for example. And the other point is that already today, during the peak production hours of the renewable electricity, the electricity market prices fall to zero during certain hours, because there's so much supply that is way above the demand during these times. And as the electricity market works today in most countries in the European Union and also Greece, this leads to buying prices on the electricity exchange. So there are already today time windows with the availability of very low price renewable electricity, but they are not continuous. They are only dedicated time windows. Okay, and that's where I come to the NEUTRON approach that we are looking at in the current ongoing project, because our goal is to design a system that makes maximum use of these circumstances that are there locally by making maximum use of this green electricity production that is already being built up in the region, by taking this volatile electricity, converting it to heat, like we have seen in the experimental plant here in the multi-test, then storing it, so using the hours when the electricity is available, store it, and afterwards converting it to dispatchable electricity and also dispatchable heat for the district heating network, which can be produced from the stored energy according to the demand and also according to the prices that the energy can achieve on the market. To show a bit how we expect this system to operate, I brought a very recent example. What I show here is the curve from the Greek energy exchange, the Hellenic energy exchange, where basically on hourly basis the electricity is traded. And what we see here is two curves. The blue curve is the so-called market clearing price. So this is in the end the determined price that that the trader has to pay for electricity when he buys it in that certain hour. And in green we have the renewable generation in the grid during the same hours. And what we see here is this example is actually from last week. So this is the first week of May this year. It's only a few days ago. What we see here already very consecutive days. We have during the noon hours, we have peak production in the renewable electricity, and the prices fall to zero. We have these in a very continuous way already. And what the system that we propose would do in this market is the following. During these hours, we take the cheap electricity either from own renewable plants that are not economically to sell the electricity during these hours because the prices are too low, or we could also just buy, the system could buy electricity from the exchange or other renewable plants that do not have an off-taker during these hours, and we use this electricity to charge the energy storage and supply heat if it's needed during these hours. These are the curves down below. We have here in red. This is actually not from the last week because I don't have the data, but from the first week of May last year. This is the energy demand curve of the heating was still in operation during this time. And what we would do is during these blue windows, we could take the electricity and do a direct heat supply via, for example, an electric boiler or also electric driven heat pump as an auxiliary system. And in parallel, we charge the heat storage. And what we then do is during the remaining times, we would use the stored energy to discharge the heat storage and provide heat to the district heating as the first effect from this stored heat. But because we are storing at a very high temperature in this concept, we can run a combined heat and power cycle in these periods where the electricity prices are quite high. So it's attractive to generate electricity during these times. And when the price is high enough, we kick in for the demo plant, the organic Rankine turbine to produce electricity in addition to the heat, or for the large scale, we would turn on the steam turbine to produce electricity with an even better efficiency. So this is the proposed operation regime of the system we propose for the NEUTRON project. And as a last point, what I would just give an example of, these are not actual values, these are really exemplary values, because the result will be part of the results of the NEUTRON project, of the economic assessment, which is not done yet. But I want to focus here on the cost structure that we have from the conventional heat generation plants compared to renewable systems. So when we look to the left, we have the typical cost structure of a conventional heat generation plant, and then compare this to the renewable alternative. But we have to say this: these are the levelized cost of energy in this example. So these are the energy costs over the payback period of the payment period for the system. In the end, in the beginning, there's an invest to build the plant, and then there are expenses during the operation. And the typical payment periods for energy projects in the range of maybe 5 to 10 years. Over these periods, they're occurring the costs. Some of them are from the operational, and the other one is from the investment costs. And the big difference here is that from the conventional system, the systems may look very cheap regarding the investment costs. So the initial investment is quite low, but during operation of the system, there are high running costs, and most of them, for example, when you're thinking of a natural gas boiler, the majority of the costs comes from the fuel cost during the operation period of the system. So the majority of the levelized cost of electricity or energy come from the fuel that you put in, that you need to buy for the conventional system. For the renewable system, on the other hand, there is no fuel cost. So the sun and wind, they don't send you a bill. So the electricity, so the energy comes basically without a cost. So the running cost is only for maintenance of this system. And the majority of the costs, which could be when you look at when you look at quite small payback periods, can be even higher than for a conventional alternative. But the majority come from the capital costs that you need to invest upfront. But the potential of the renewable system comes through some different effects. The first one is regarding the proposed system, which is basically would be a first of its kind system with a very high grade of innovation. And we see here a very big potential to have here additional funding through, for example, innovation funds, and also in the case of Kozani, through the EU Green Deal programs that could be applied here to projects greening the district heating and energy sector. So if there's a co-funding for this investment costs, the effect is very high on the renewable system, but would be very low if you apply it to a conventional system using kind of regenerative fuel like hydrogen or biomass, for example, because in these technologies, funding for the capital costs would only apply to the small part that is related to the investment itself, while from a completely renewable power system, it applies to the majority of the cost that the system causes. And the second effect is if the system is run for a few years, where it is paid off, then afterwards there is no capital costs anymore. When the system is paid off, basically there's only the maintenance costs remaining for these systems. And this is basically the point in time where these systems really pay out the initial investment, because the lifetime of the systems is way longer than the usual payback periods for these systems. So this is something that I wanted to show here, just to keep the structure in mind, and also the special levers for the renewable projects that are very huge and should be applied to these projects.
This picture to say something.
Okay. Josh, the floor is yours.
And I divided also the process and then Εξηγώντα το κόστος, οπότε θα ήταν αν το παραδοσιακό σύστημα από αν θα έχουμε την επιδόση, βλέπετε ότι πάει χαμηλότερα από ό,τι είναι το προηγούμενο σύστημα. Και αυτό που λέει ότι όταν πληρωθεί, περάσει η περίοδος, πληρωθεί το πρόβλημα, η τιμή που μπορεί να κοστίσει εδώ είναι ελάχιστη. Αν τη στιγμή με διαστάσεις που κοστίζει, τότε είναι αμύστη. Τώρα, το κεφαλαίο. What is going to be the amortization? How many years?
We do not know yet. This is part of the economic assessment in the NEUTRON project.
How did you do your calculation?
Sorry?
How did you do your calculation? What's our number?
It's not let's suppose that we have the first solution where the capital cost is ours and not get funding from the European Innovation Fund or anything else. Say that as an example, as a basic example. How many years do we need in order to alleviate the capital cost from the operational cost?
Okay. Ma io sto parlando perché sto per όταν το κεφάλαιο είναι πάνω από το μας. Αυτό θα πέσει στην πραγματικού υπολογισμού, δεν ξέρω το γύρω στα 5 χρόνια. Πάνε στις επιδόσεις. Σε 5 χρόνια, τι θα πληρώνεις για την ενέργεια μπορεί να είναι χαμηλότερη από ό,τι πληρώνεις. Είναι ένας τρόπος να διατηρηθεί το σύστημα της διακυβέρνησης.
E voi potete stare in Australia, we have the time to study later, so I would like to come back to the
Is there a debate fundamental for
I think that's it.
one second?
So what I can give you maybe is a range that we experienced during similar studies that we did for projects here in Germany already for different clients. And usually when we are comparing it to systems burning natural gas, we usually come around in a range of 10 to 15 years. This is maybe a range to give where we land with these projects when we are comparing it to natural gas burning systems.
It would be higher than if you have maintenance in Germany. Because produce so we will be open on you and we will have technical service for with the framework that will provide us with the knowledge that will be possible.
Yes, but yes, but there I can also say basically for the offering of the system, we as an EPC we are quite flexible on this special storage system. The one we saw there also on the multitest. There have been developed patents and so on for this special storage system. But we can discuss about but this is very detailed already to do the different models where, for example, the thermal cycle and so on. It is not mandatory to be built by one special manufacturer. There are many on the market offering, for example, the construction of steam cycles, and also what could be important is what we propose here is a system that utilizes technology that is very familiar in the region, in Western Macedonia. It's the thermal power cycle, which is in a very similar kind already applied in the lignite power plants running today. So the maintenance of such a system could be very well be done by personnel that is now needed in the lignite power plants, for example. So this could be can be an additional benefit for the region in this case. So for the maintenance, they are not reliant on the supplier of the system.
Okay. We will have. Was it the last presentation?
Let's see. Yeah, the last slides would be the summary. If it's too
yes,
the time schedule is too tight,
yes.
Then
if you can use 1 minute, maybe.
Okay.
To
okay. Then I would just shortly recap what we see as the benefits for the municipality in Kozani. So the first one, I call it participation, because there's this ongoing mega trend in the region, whether the people approve this or not. But we saw that the renewable project development in the region is already massive, and this is happening. And I don't think that this will be completely disrupted. So the solution we propose here offers a possibility to participate in this trend of renewable energy transition. The second one is together with currently available funding opportunities, and this time window will be limited. The solution will offer competitive energy prices for the future, and especially for the later periods when it's realized and paid off, because afterwards the benefit will remain for the region and the city. And the last one, but I think this one comes more and more into focus, is the independence, because on nearly all fossil fueled energy systems there's a dependence on imported fuels. And nowadays, with the green transition and the renewable energies, it's for many regions, it's an opportunity. In the Kozani case, it's an opportunity to get back to the independence that was in the past generated by the lignite extraction, but in the future it can be based on the renewable energy production, which is happening locally. Okay, so this is my conclusion. My conclusion for this topic. So the potential for the geothermal heating is low in the region, and the alternative technologies for the green district heating face some specific hurdles in the region where some preconditions are not optimal for the utilization of these technologies. And in parallel, we have this fast and already ongoing development of renewable electricity productions, resulting in an imminent need already today for energy storage systems to go alongside with these production capacities. And what we suppose here is this combination of energy storage with the combined heat and power output provides here unique economic benefits to the region in this special setting with the renewable energy production. Okay, so thank you everyone, and I already noticed that the interest is very high, so we will continue the discussion.
Yes, I think we can continue the discussion.